Right, at number 12, I'm finding the inverse. So I need to take this set of numbers, and I'm going to attach the identity matrix for 3 by 3 at the end. Okay, so my goal is to get the left side to look like the right side, and the right side will change and end up being what we consider to be the inverse. Okay, so my first short-term goal is to get a 1 in that top corner, and there is one already, so yay. So then I need to get zeros underneath it. So I'm going to take row 1 and add it to row 2, and for row 2. And then to get rid of the bottom 1 in that first column, I'm going to take negative row 1 plus row 3, and for row 3. Alright, so, oops, very sensitive scrolling this thing. Okay, so, row 1 I'm going to keep. And, let's see, so we're going to add the two rows together. So I get a 0 there, a 2, a 5, a 1, a 1, and a 0. That wasn't too bad. Let's see, negative row 1, so that puts a 0 there. Negative 1, negative 2 plus 0, negative 1 plus 0, 0 plus 0, and 0 plus 1. Okay. My next goal is to get a 1 in the middle. I would like to avoid fractions if I can. Not that I don't like fractions, but I see that negative 1 at the bottom, and row swaps are usually easier to do than any other option. So I'm going to swap out row 2 and 3. And that'll put a 1 where I need it to be. 0, 2, 5, 1, 1, 0. Okay, so then I'm going to take negative row 2 in for row 2. And that'll put that middle one at a 1, which is what I want it to have. Okay. Alright, so I need a 0 above and below the 1, and I lucked out, and I already have a 0 in one of the spots, so I just need to get it below it. So I'm going to take negative 2 times row 2, add that to row 3. Alright, so row 1, I'm just going to copy. And let's see, so row 2 would be the same. And row 3 this time, so negative 2 times 0 plus 0 is 0. Would be a 0 as well. That would be a negative 4 plus 1 is 5. Oh, that's convenient. Negative 2 plus 1 is negative 1. Negative 2 plus 1 is negative 1. That would be a 1. And that would be a positive 2. Alright, let me scroll down here. Okay, so then I need zeros above it. And they both look like if I just take row 3 and multiply it by negative 2 and add it to row 2, that'll take care of that spot. And then the same thing, negative 2 times row 3 plus row 1, and for row 1. Let's actually do the row 1 first, since that's the, I guess, top of it. Okay. Alright, so negative 2 times 0 plus, okay, so I get a 1 up top, then a 0, then a 0, and that's what I wanted. And then 3, negative 2, and negative 4. And then row 2, so same thing. Negative 2, okay, so I get a 0, a 1, and a 0. And then 3, negative 2, and negative 5. And 0, 0, 1. And then it's that same set of numbers from before. Alright, and so our inverse matrix is that set of numbers there. Number 13 and 14, I am doing system of inequalities. So my first task is to actually sketch a picture of these inequalities. We talked about doing the cover-up method on this. So if I cover up the y, I get 2x equals 6. So I get x is 3, and I get y is 2. So I can go to 3 and 2 and put points. It's a solid line for that one. And then I'm going to just pick a test number. If I put 0, 0 in there, I get 2 times 0 plus 3 times 0. So I get 0 is less than 6. That's true. So that's shaded towards the origin. And then I'll do the other line. The other line, if I cover up, I get x equals 2. And I get y equals negative 2. So 2 and negative 2. Again, solid line. And then let's do the origin in that one. So 0 minus 0 is 0, so 0 greater than or equal to 2, and that's actually false. So I'm going to shade away from the origin. And so looking at my sets of arrows there, I can see that the shaded part is right there at that bottom part of the x. All right, number 14. We actually just looked at this. X minus y is, well, we looked at greater than 2, so we know it crosses at 2 and at negative 2. And if greater than was below, then less than would have to be above. So it'd have to be shaded towards the origin. The other line, let's see, so this would be x equals 6 and y equals negative 6. So 6 and 6. And let's see, so we'll test this. Let's try 0, 0, the origin. And so 0, 0, so we get 0 greater than or equal to 6. That's actually false, so it's going to shade away. And then we have a slight problem in that there's two parallel lines and they're shaded opposite of each other. So there's no overlap. So in this case, we would have no solution. All right, number 15, we are asked to solve a system that's nonlinear. We sort of get to pick a method, whether it's elimination or substitution. Number 15 actually is a good one to use elimination on. And so I'm going to rewrite that top equation as y equals 4 over x. And then I'm going to substitute that into the bottom equation. So 2x squared plus 4 over x squared equals 18. So that's 2x squared plus 16x squared equals 18. And then I'm just going to solve that. Now, I got a denominator that I'm just going to multiply everybody by x squared. So both sides get x squared. So that'll give me 2x to the 4th plus 16 equals 18x squared. And then what I'm going to do is I'm going to bring the 18 over. So 2x to the 4th minus 18x squared plus 16. And this looks very, well, it's a quadratic type problem. I do see that I can take a 2 out. So 2 times x to the 4th minus 9x squared plus 8 equals 0. And I'm going to try to factor that real quick now. X to the 4th I'm going to break up as x squared and x squared. And the only way for that middle thing to say 9 is if it was 8 and 1 at the ends. And they both have to be minus. Now, the interesting part here is that x squared minus 1 can actually factor again to x minus 1, x plus 1. Now, x squared minus 8 isn't quite a perfect square, so I can't really do anything with it. Let's see, and then what? So we get x minus 1 equals 0, x plus 1 equals 0, and x squared minus 8 equals 0. So that gives us a 1, a negative 1. Now that's interesting that it's x squared equals 8. So if I take the square root, I get plus or minus the square root of 8. And let's see, that would be 2 times 2 times 2. So I get a pair of 2's that come out. So 2 square root of 2. All right, so plus or minus 2 square root of 2. So actually I have 4 numbers now. Okay, so let me go back up. We said y is 4 over x. So I got to find a y value that partners up with all of these. So I'm just going to go one at a time down the list. So if x is 1, y would be 4 over 1, or 4. So that gives me the ordered pair of 1, 4 as a solution to my system. If x equals negative 1, I get y equals 4 over negative 1, which is negative 4. Then we get 2 square root of 2, so if it was positive 2 square root of 2, I get 4 over 2 square root 2. Now, the 2 divide out to leave me with 2 over square root 2. And we have actually talked about rationalizing, so I'm going to rationalize that real quick, which gives me 2 square root 2 over 2. Again, the 2's divide out, and I'm left with square root of 2. Okay, so the moral of the story is, when x is 2 square root of 2, y is positive square root of 2. And then last but not least, put a negative in there, and honestly, all that's going to do is make our y value negative. Because it's just putting a negative in the denominator of the fraction, so it still ends up being negative when all said and done. So those 4 points are the solutions to our system. Okay, number 16. All right, so this would be another good practice for, I like elimination on this one. And so I'm going to multiply, let's multiply the top by 2 and the bottom by negative 3. All right, so the top I get 6x squared minus 4y squared equals negative 10. The bottom I get negative 6x squared plus 3y squared equals 6. And so I can add those together, and I get the x squareds cancel out, and I get negative y squared equals negative 4. So if I divide out the negative, I get y squared is 4, so y is equal to plus or minus the square root of 4. So that means y is equal to plus or minus 2. So I actually have 2 y values. Okay, so then I'm going to go back and pick one of my equations. Let's do the 2x squared minus y squared equals negative 2. And let's see, we're going to do this twice, so let's do it for positive 2. So I get 2x squared minus positive 2 squared equals negative 2. So 2x squared minus 4. We'll add the 4 over. So that gives me positive 2. Divide by 2. And so when I square root that, I get plus or minus the square root of 1. Okay, so far, my ordered pairs, that actually is plus or minus 1. So I get positive 1, comma, let's see, positive 1, comma, 2. Now, hold on a second. This has been sort of confusing me for a second, bothering me. Okay, it's actually y equals 2. Oddly enough, I substituted it correctly, I just didn't label it correctly. Okay, so anyways, I get a positive 1, comma 2, and I also get a negative 1, comma 2. Okay, now, when I try the y equals negative 2, Okay, I'm going to set this up, but we're going to notice something interesting here. Okay, now, if I square a negative 2, I get a positive 2. So it's 2x squared minus 4 equals negative 2. Well, guess what that is? That's the exact same problem we just worked out. So I already know that x is plus or minus 1 in this case. So I can come over here, and when x is positive 1, y is negative 2. And when x is negative 1, y is negative 2. So I get 4 sets of points based off of those different x and y values. So there you go.